Even if you have worked with SAP EWM for many years already, its material flow system is definitely not easy to understand. My name is Hendrik, and I promise to you that in roughly 15 minutes from now, you've understood the MFS basics and how they interact. And with this video, I show you what I call the MFS Map. I've always been missing something like that, a standard map for EWM MFS. So when a student reached out to me by the end of last year to mentor him with his bachelor thesis, I said, hell yes. And we were trying to build something in that direction, a reference model that somehow visualizes all the main and important layers that have to do with EWM MFS. I'm confident that only once you've understood the main objects and components and the layers, only then you're able to dig deeper into the details and the complex features and processes around EWM MFS. So I was one of the consultants who helped Max to develop this reference model, and we handed in his thesis by the beginning of the year. And over the past months, especially the past weeks, I took his version of the model and fine-tuned it and improved it and changed it at many different places, so that I now think it's really comprehensive with the current state. I'm really satisfied, and I decided that I'm going to share that with you. And I also decided that I want to make my current version of the model a community project, an open source project. So I will share the source file at the end of this video, and I will also explain at the end of this video what I exactly mean with open source community project in this context. And getting access to this file also means for you that in the future everybody can have such a nice painting here in the living room, for example. That's where I took it from. We decided here to replace the TV with this painting. Now my wife is very happy. All the friends visiting us are asking me where I got this from, and the kids want to have it, and everybody wants to have it. And you will now also be able to get it and find a favorite place at home where you can put it on the wall. But before we come to that, I will guide you through the map. We make a quick walkthrough together. I will show you the separate and single components of the current version, and at the end of the video, I will then share the details about how to get it. It is important to mention here that despite of the fact that we are talking about the material flow system here, it is also possible to use this component of EWM as a pure integration layer. So you could use it to connect hardware which is not responsible at all to move handling units throughout the warehouse. That could be, for example, these Cardex paternosters or pick-by-light systems where nothing is moving. So basically every kind of subsystem which can be integrated via TCP/IP socket connections or RC-based middleware, for instance. But for this model here, those are not in scope. Now we are really focusing on automation subsystems which are moving handling units from A to B, because only those tackle the full scope of EWM MFS. So right now you see the whole model here, but I will guide you through the different components now step by step. We will start with what I call the foundation, and this is EWM Core, organizational structure and master data. So all MFS components and processes are also built based upon storage types. For example, conveyors or racks, even though they are automated, they are also created as storage types. You have activity areas covering bins in one or multiple storage types, and you have resources operating in those storage types. A quick look into the real world. This is the example we will be working with in this video. Please don't concentrate on the tiny little details which are not 100% accurate here. We will work with one pallet conveyor system and one automated pallet high bay, which is being served by automated storage and retrieval systems. And in MFS, the conveyor would be a storage type, the pallet rack would be a storage type, there would be bins within the pallet rack, there are bins on the conveyor. I will come to this in the next step. And we will have resources operating the automated storage and retrieval system here. So that already brings us to the next layer, which holds the core MFS objects. Those are communication points and resources. And you see that here with this visualization of having the same object that we have in the core EWM, but with a highlighted border, and that should reflect the fact that we are actually reusing objects that we have in EWM Core, and we are giving them special features. So we don't have a normal storage bin anymore, but we have a communication point with special characteristic and functionalities, like special warehouse process type, which is used to move handling units from here into the rack, or a follow-up clarification storage bin, which is used to move handling units with an error code to the clearing area. And also the resources have special characteristics which are not used in EWM Core, but only used for EWM MFS. And coming back to our real-world example, here I try to highlight the objects which are relevant for MFS. So imagine not the whole system, not every single physical component needs to be mapped or reflected in EWM. We only create those objects in EWM MFS which are relevant for communication with the subsystem. So only those points in the physical material flow where we need to exchange data with the subsystem are created within EWM. And they are created based upon EWM Core objects by giving them additional characteristics and features. You see it highlighted here. For example, the resources, the cranes operating the RSRS, or specific points on the conveyor where data is being exchanged between EWM and the subsystem. The next component is the handling unit. I placed it here, but it could be placed anywhere else, because the handling unit is just affecting all the different components and areas. The handling unit is our MVP here. The handling unit is representing the physical stuff that we move, and the handling unit is the reason why we need everything else. It is highly recommended if you work with EWM MFS that you work with handling units and handling unit warehouse tasks. It is best practice. It is technically even required at a couple of different places. I will come to that when we talk about the routing. It is possible to bypass also that requirement. I will not go into detail here. If you have technical questions related to such things, I recommend you reach out to experts like Memetan or Helios, who have a much deeper understanding of this whole MFS topic on the technical side than I do, and I'm pretty sure they are happy to answer all your questions. I will put their LinkedIn profiles into the video description. Quick look into our visualization here. In this one, I highlighted the object. So in our example, we are moving pallets, and that means that every pallet that we are moving is a handling unit, and in order to move this pallet, at some point we need handling unit warehouse tasks. Now there is some slight differentiation in regards to the routing approach that we are using, but I will come to those differentiations here within the next minutes. We will now come to the most difficult components of the model, which is the routing logic and the warehouse tasks. The routing logic is the logic that decides which intermediate positions on the material flow system the objects, or the HUs, have to visit up until they reach the final destination. And the warehouse task, in the same way as warehouse tasks are used in core EWM, are used to post quants. So assuming we are using handling units, we can replace this term with handling unit in this context. So the warehouse tasks are used to post handling units from A to B. This is not different in MFS. They have the same purpose, but there is a huge difference related to the usage of warehouse tasks between the different concepts for routing. And we will have the case conveyor routing as one option and the layout-oriented routing as another option, and we will now look into the details of those two different options. For all MFS experts out there, bear with me if I'm skipping some details now. There is not enough time to go into the details of the LOSC and the case conveyor routing in this video. If you or anybody else is interested in those details and differences, please put a comment under the video and I will think about how I could give you a deep dive in a separate one. So with this video here, the objective is to give you a rough understanding of the components, so that you can then dive deeper in the next step. For now, please focus on the right side of the layout here. We will first look at the layout-oriented routing. And what I want you to look at first is at these big arrows here at the background. And I painted these big arrows to visualize the initial situation in which a first telegram which moves an HU from A to B is sent from EWM to the subsystem. So our starting situation is one where the first or the next telegram for the next destination is to be sent. And with the layout-oriented routing, the starting point is always a warehouse task. So the starting point of our outgoing, from EWM perspective, outgoing arrow is always a warehouse task. There is no telegram to move an object from A to B without a warehouse task if we are going for layout-oriented routing. And the task is created. The standard customizing is evaluated based on the source and destination of the task. And if there is an intermediate bin between the source and the destination, we create an intermediate task. You know that probably also from non-MFS application of the LOSC. And for this intermediate task, we then determine the queue. And if the queue is MFS relevant, only then a telegram is sent to the subsystem. So EWM initiates and EWM pushes, I highlighted that here also, pushes the telegram to the PLC. Telegram is being pushed down. The PLC replies with a confirmation at some point when the HU has reached the given intermediate bin or some clarification bin or whatever in exception scenarios, but then this telegram is being processed, the task is confirmed, and then potentially another follow-up task is created and another telegram is created and pushed to the subsystem. Now, if you understood that approach in general, you understood the core of the layout-oriented routing. This has the disadvantage that with every telegram which is coming in, we have to confirm the task. For that purpose, we have to lock the HU, we have to create a new task, and only then we can send the telegram. And that takes a while. That might be 500 milliseconds, maybe a second, maybe a bit more. In a palette environment, like we saw it on this example layout, that's usually not a problem. So this is layout-oriented routing. Okay, so that also means in a layout-oriented routing environment, the subsystem will not do anything unless EWM does something. Also physically, the objects will stop and wait for EWM to send next destination. And this is different in a case conveyor environment. You might have seen that also in highly automated light goods warehouses. The objects are always moving. And the objects are always moving, and the subsystem is actively requesting destinations from EWM. So the initiation of the communication of the next destination is done by the subsystem. So that's slightly different. That's a little bit difficult to understand. at the beginning, but I hope that with this graphic I will make it a bit easier for you now. I want you to focus now on the left part of the graphic, and you already see a big difference with these big arrows in the back. You see that in comparison to the LOSC approach, where the initiation of the telegram processing is an outgoing one from EWM perspective, based on the warehouse task, and with the case conveyor routing, the initiation of the telegram processing and the communication of the next destination is an incoming telegram. That's why I also marked this here as a pull approach. So the subsystem is pulling information from EWM. And this telegram is coming in as a so-called routing request. And EWM then reads the combination of the case conveyor routing table, which is sitting in the customizing, and the movement table. That is a database table which is not used anywhere else out of the MFS context. The EWM MFS HU move, which could potentially store a rough destination. So you might have a combination of a handling unit and the current position and the planned destination. So that could be used as a reference to determine the next intermediate position. And potentially, I didn't mention that here, I might want to add it, we would also analyze and evaluate open warehouse tasks. So if you potentially on the outbound side, so outbound process, the HU needs to move to the staging area or to a workstation, and this open warehouse task would help the case conveyor routing to find intermediate destinations. On the inbound side, you're usually working with rough destinations, so you have written a potential put away destination for the given handling unit into the movement table, and then the case conveyor routing is reading this record in the movement table without the need for a warehouse task. In this case, we create then this outgoing telegram and send this to the subsystem, but we do not necessarily create or post warehouse task in this context. We can do that, but it's 100% decoupled from the telegram processing logic. That's why I painted it here as a separate file. So if it's helpful, for example, for transparency for the users, that's why you would usually want to do this. We can do a so-called after the fact movement posting, which is executed after the telegram processing, and that posts the HU usually to the communication point where the telegram was received, but theoretically you could post the HU also to any other communication point, potentially one which it has not reached yet, but it's going to reach it. But usually you would post it here to the CP where you received the telegram, and then you have a almost in time reflection of the current position of the HU, but technically it's decoupled, and that also means the creation and the confirmation of the warehouse task does not cause a delay of the telegram processing. And that's why we have much shorter round-trip times here. And that's also why this routing approach is much better suited for fast-moving environments, like you would see that, for example, for highly automated light goods warehouses. And I think that's a very interesting approach, and finding here that theoretically you could work with the case conveyor routing approach without any warehouse tasks for the intermediate steps. Potentially you could move an object, so a handling unit, through a complex automated material flow system without creating any warehouse task at all, and only with the final confirmation, so the final confirmation telegram, you then create an asynchronous posting of the object to the destination, which was communicated with the final confirmation telegram. So you could theoretically set up a very lean material flow system here, but that would also be very intransparent for the users. That's why I mentioned the best practice approach is these after the fact posting, this asynchronous postings decoupled from the warehouse task once the telegram has been processed and the HU has left the given communication point. Having said that, or with this information in mind now, having understood those two concepts, I have a question for you. And I have a question especially for the SAP EWM MFS development team. Here's my proposal. Wouldn't it be better and much more meaningful and technically correct if you would get rid of the terms layout-oriented storage control or routing and case conveyor routing in the context of the MFS? Because both routing approaches are layout-oriented. So both approaches are considering the specific physical layout of the automated system, of your material flow system. So that's not a term that you should use for the differentiation. And the case conveyor routing logic is also not slayly used or designed for cases. You can use it for pallets in the same way. In the same way as you could use a layout-oriented storage control and routing approach for cases. And nothing prevents you from doing that. And my proposal is that we change the wording for the two approaches to warehouse task dependent routing and warehouse task independent routing. Because that is, from functional and technical perspective, the one decisive factor that differentiates the two approaches. We could add, if you want, and that's what I'm going to use from here onwards for the future to make it easy to understand for you. We could say warehouse task dependent routing based on the LOSC and warehouse task independent routing based on the case conveyor logic. I think that would be much more meaningful, easier to understand, and would also highlight the functional and technical difference between the two approaches. I would love to hear your thoughts, especially, as I said, the thoughts of the SAP MFS development team, and then I might tackle that topic again in a separate video. We could also talk in this context about, there are so many other topics related to this routing approaches. It's also important actually to understand that you could mix both approaches. Sometimes you even have to. You could use layout-oriented storage control at the same time as you could use case conveyor routing logic in one material flow system. So at one communication point, you might create the telegram without creating a warehouse task up front, and at other communication points or in other situations on the conveyor or on the interface between conveyor and resources or on any other kind of automation equipment, you could start with the LOSC and first create the task and then create the telegram. So you need to mix it up based on what fits better, but we can go into detail here on a separate video. Let's first try to suggest my proposal for this new wording, and based on this proposal I adjusted the map a little bit, and I will now show you the adjusted version, and I would love to hear your thoughts and your ideas about this approach and this wording. So here you can see now what I changed. If you concentrate on the left part first, on the one which is based on the case conveyor logic, which I labeled now as warehouse task independent routing. So the communication loop is initiated by the subsystem. The first arrow is pointing towards EWM. So the subsystem is pulling information from EWM. The telegram processing logic will catch this routing request. It will then look at the combination of case conveyor routing table, movement table, and warehouse task, and will reply with a destination for the routing request. And in parallel, decoupled from that, independent, we have potentially a warehouse order and a warehouse task which is doing the movement posting after the fact. And then if you look at the right side now, where we see what I called layout-oriented routing before, and I now changed that and labeled that here as warehouse task dependent routing. So we are pushing from EWM to the PLC. So the first arrow here on the left side, which initiates the communication, is pointing from EWM to the subsystem. So we have the warehouse task confirmation and creation first. Creation based on the layout-oriented storage control, which is used in this context for MFS. Can also be used anywhere else without MFS. We use it for MFS here. We create a task, assign the task to a queue. If the queue is MFS relevant, we trigger the telegram creation based on the task. And then at some point, we close the loop with the confirmation of the task. And here, again, we go through the telegram processing logic in the same way as we do that for routing requests. And here, we initiate the task confirmation based on that. So with this, I think we have a much more meaningful description of the two approaches, also reflecting the functional and technical differences.
Before we proceed, just a quick reminder that this channel lives from you subscribing and of course hitting the like button. So please do that real quick before we proceed with the next point. Thanks a lot, and back to Hendrik.
The next group of components that you see here is what I call the MFS communication objects. So this is the logical PLC as well as the communication channels. You could have one or multiple channels for each subsystem, but the PLC and the channels within EWM hold details about the telegram processing, for instance, the structures being used for the header, the lengths, the start and stop characters, and the channels. The PLC also hold data about the connection itself to the subsystem. So stuff like the IP address or the port, which is used to talk to the subsystem and establish the communication connection. And then you see here, and I mentioned that already at many places before, that we have the telegram communications. So telegrams are those strings of data which are being exchanged between EWM and the subsystem, and there is an optional layer here with the middleware. So this is something you might see in older projects back in the days when EWM was not able yet to talk directly via TCP/IP and the ABAP push channel technology to the PLCs. So you would potentially see here middleware like planned connectivity and EWM talking to this middleware with RC-based integration approaches, and then the middleware handling the TCP/IP communication with the physical PLC. So now we already come to the final layers of the MFS map, and they are composed of the physical PLC. So you have a physical object sitting within the warehouse, but you also have a software component here, of course. But this physical PLC is receiving the data strings from EWM and sending data strings to EWM via, for example, the TCP/IP connection. And it's using this data to process it and potentially make decisions or apply specific logic, activate specific output signals, and then communicate via industrial networks or field bus systems with the physical hardware. So that's mainly sensors and actuators, but those are then in a broader range, also motors along with their drives, identification systems like scanners, I/O modules, and those in its whole then represent the automation hardware and the equipment. So that's what you know, what you've seen in warehouses like conveyors, cranes, robots, AGVs, and stuff like that. So this is then the physical layer, the actual hardware. Just having a quick last look into our graphic here. So what we are talking about is, you might have seen that in the warehouse. Usually it's a big white box with a lot of cables going in and out, and this is holding all those modules receiving and sending data via the industrial network. This is connected to all those components that I mentioned before, for example on the conveyor or the cranes or other kind of automation equipment. And this hardware layer comprehends my EWM MFS map. Just to give you a final overview, we have our lowest layer here with the automation equipment. We have the physical PLC exchanging data with the automation equipment on the one side, and the telegrams on the other side for the communication with EWM. There is this MFS communication layer with the logical PLC, the communication channels holding the information about how to communicate and integrate. And we have the different routing approaches to decide where a specific object is going to move to next. And those components also hold the telegram processing logic. We have the handling unit as one essential object in EWM, the one which is moved logically and physically. And we have the organizational structure plus master data in EWM Core, which is a foundation and which is enhanced by MFS objects, which enrich the EWM Core objects with specific characteristics and functionalities. As mentioned and promised already at the beginning of this video, what I showed to you today is not just a reference model, but it's really a map and a tool for learning, understanding, and communicating those concepts. So if you are new in this topic, in this area, if you have never used MFS before, it gives you the possibility to understand the main objects and components, to then dig deeper into the details in the next step. And if you are already experienced, if you've done MFS projects already, you might have had the situation that you need to explain it to somebody else, to a junior consultant or developer, or to customer, to a key user. And this map should help you with this exercise in the future. And as you know it from my channel, I don't want you to only consume that stuff. I want you to actually use it. I want you to use the content from my videos and from my blog and apply it in your real-life projects, in your training sessions, or wherever. And that is also why I mentioned at the beginning of this video that I'm going to open source this map. You can download it on my blog. I will put the link to the blog post in the video description. You will find a draw.io file, and you can then open and improve, change, do whatever with it with draw.io, which is also an open source tool, so nobody needs to pay anything to be able to change that document. And the only thing I'm asking you for in exchange is that whenever you find spots where you think the map is not comprehensive, things are missing, things are placed in a wrong order, I want you to reach out to me. You can do that via comments here in the video description. You can do that via direct message on LinkedIn, or, and that is my preferred approach, you can use the hashtag MFS Map and write or publish your suggestions on LinkedIn. That is the easiest option also for the community to then provide feedback to your ideas. And I'm planning to collect all those ideas now within the next 6 to 8 months, and then make a second video about this map where I present you along with your suggestions, and we create one version 2.0 of this map together as a community project. And with that, it is time to close this video, but I don't want to close it without a big shout out, a big thank you to Max for the inspiration. I will link his profile in the video description. A big thank you to you for hitting the like button, for subscribing to this channel, because that's what keeps this whole thing alive here. That's what motivates me to create new content for you. With that, as usual, happy learning. Good luck within your projects, and I hope to see you with the next video on this channel here again. Bye bye.